we're going to look at balancing equations, but we're going to use a picture and a balance scale to kind of help us visualize what's going on. Do you know if you have an equation like this, 6x plus 2 equals 10 plus 4x? Well, if these two things are equal, we could pretend that maybe this was a balance. And the x's, well, here they are in boxes. So we're showing we've got a pictorial solution here. We've got 1, 2, 3, 4, 5, 6 x's. And the units, each ball represents one, so there's two balls. On this side, there's 4, 5, 6, 7, 8, 9, 10 balls and 4 x's. Well, we want to figure out what x equals. So what do? We could, if we take away 4 x's from both sides, we'll just be left with the 2x plus the 2, and it'll equal this 10. Well, that's what's going on when you solve an equation. It's like a balance, and you're just taking things away. You take away 4x's, you get 2x plus 2 equals 10. And then we would like to have the 2x by itself because we want to find out what x is. So we take 2 green balls away from both sides. Well, they come off of here, and they come off of here. Instead of there being 10, now there's 8. So the 2x equals 8. Now, gee, if 2x equals 8, maybe if we split this pile into 2 piles, there'd be a pile of 4 and a pile of 4. We'd have an x, and 4 and 4. We can see that x equals 4. Each x must be 4 for this to be balanced. And because we did the same thing to both sides of the balance, everything is okay. We haven't broken the rules of logic or mathematics. Now, the next part here, this goes with an investigation that we're doing. There's something that I got from this Canadian text called algebra tiles. Now, the long bars represent a variable, and if they're red, they're negative. If they're yellow, they're positive. So there's 1, 2, 3 minus c's here, right? And then 1, 2, 3, 4, 5, 6, 7 positive 7s. There's 1, 2, 3, 4, 5, 6, 7, 8 minus 8. So each one of these represents a unit, and there's 8 of them. But there's 2 c's here, like this. Now, the way this game works is if you add if you take away, add a red C and you put it on top of a yellow one, they'll cancel each other because this is +2 and the red ones are negative. So they're kind of like antimatter. They just sort of, they cancel each other out. That's the way this game's played. So what are we going to do to both sides? We are going to add 2 red variables, 2 red tiles. Well, 3 plus 2 makes 5 here. That's why it says -5 in the equation. But if we add 2 red ones to these yellow ones, they're gone. And all you're left with is -8. So that's what you have here. You have a -5c equals -8. The red ones are negatives. Okay, we would like these 7 yellow ones to go away so we get the variable on the left side, these red tiles. So what do? We add 7 negatives, 7 red ones. That's subtracting 7. And when you put a red one with a yellow one, it makes it go away. So we put 7 of them there. 7 minus 7 is 0. And you've got now -5c. And we've just added 7 more to these 8. There's 15. But let's rearrange those 15 in groups of 3. There's 5 groups of 3. Well, hey, now each one of these is a c. It's -5c equals -15. But from this picture, if I divide by 5, I get 1. If I divide 15 by 3, I get 3. So minus c equals -3. I can see that each one of these variables equals 3. Hey, these tiles, I think they're kind of cool because they sort of work. Now, we don't want to know what a minus is. We want to know what a positive is. So what we'd have to do is just add 2 yellow tiles to both, add a yellow tile to both sides, and add 3 little yellow ones here. These would just cancel. You'd get 3 little yellow ones on this side. You'd get a yellow one on this side. You'd end up with c equals +3. They say in this book, just flip the tiles and it works. Well, it does, but I needed to do something to both sides to see that C equals 3. We kind of multiply by -1 in the arithmetic. Okay, now you'll have to, maybe you can get your own tile. So it's not hard to make red and yellow or just two different types of, you could make your own like this and try doing algebra with algebra tiles. I think it's pretty cool. Okay.